Welcome to Lakshmi Chemistry YouTube channel. Chemical reactivity of alkane. Alkanes are chemically inert compound because of they do not have any reactive functional groups and they are stable in nature, and these are not attacked by acids, bases, and oxidizing or reducing agents at ordinary temperatures. But alkenes undergo addition, substitution. Sorry, alkenes are participated in substitution reactions with halogens in the presence of sunlight, that is called free radical substitution reactions. First, free radical substitution reaction of alkenes. Alkenes undergo free radical substitution with halogens in the presence of light. The presence of light. For example, alkane plus halogen in the presence of sunlight. Alkyl halide. What is this? Alkyl halide. Alkyl halide is formed. You can observe this mechanism of the reaction. This reaction proceeds to three steps. Three steps. The first step is chain initiation step. Chain initiation step. The presence of sunlight, halogen atom undergo homolytic cleavage. In the presence of sunlight, halogens undergo homolytic cleavage to form halogen radicals. X dot halogen radical. This step is called chain initiation step. And the next second step is called chain propagation step. In this step, halkide free radical or halogen free radical reacts with alkane to form alkyl radical and HX. These alkyl radical again reacts with halogen and form alkyl halide and halide radical. Halide radical. These halide radical again reacts with alkane and again form alkyl halide and also alkyl radical. This alkyl radical again reacts with hydrogen halide to form same. This step is continuous step, and this is the second step. The next one is third step. The third step is called chain termination step. Chain termination step. What happening is termination step means here when two halogen radicals are combined to form halogen, or when two alkyl radicals are combined to form a new alkane, or one alkyl radical and one halogen radical combined to form alkyl halides. These three, if two halogen radicals are combined, or if two alkyl radicals are combined, or if two alkyl or halogen radicals are combined, the reaction was stopped. This step is called chain termination step. For example, I am taking one example, that is methane reaction with chlorine in the presence of sunlight. What happened? The product is methyl chloride and HCl. In the first, you can observe the mechanism of this reaction. First step, chain initiation step. In this step, what happening? This chlorine under the influence of sunlight, under the presence of sunlight, chlorine radicals are formed. And the next second step, this chlorine radical reaction with methane to form methyl radical and HCl. This methyl radical again reacts with chlorine to form methyl chloride and Cl dot. This is the chain propagation step. Then next, chain termination step. In this step, two chlorine radicals are combined to form chlorine, or two methyl radicals are combined to form ethane, or one methyl radical, one Cl radical combines to form methyl chloride. This is the termination step. This is the halogenation reaction, or what is this halogenation reaction or chlorination, we can say as chlorination reaction or free radical substitution reaction. Then orientation of halogenation, that means where the halogen atom is attached. For example, if the halogen atom is combined to hydrocarbon, if two or more products are possible, if two or more product are possible, when where is the which one is the major product and which one is the minor product, and the where the halogen atom is predominantly attached, that is called orientation. For example, I am taking propane. If propane on reaction with chloride radical, chlorine radical, here if chlorine radical reacts with propane, here two types of products are possible. For example, this first carbon or primary carbon, this is the secondary carbon, and this is also a primary carbon. When primary carbon containing hydrogen loss of H plus H dot ion, H dot ion, what happening here? Primary free radical is formed. If secondary carbon loss of H dot, what happening here? Secondary free radicals are formed. Secondary free radical is formed. Already you know that the ease of substitution is tertiary greater than secondary greater than primary greater than CH dot. Okay, secondary free radicals and primary free radicals, and you can compare these two. For example, primary or secondary free radicals, you can comparing these two free radicals. Secondary free radical is more stable than primary free radical due to the inductive effect, electron donating inductive effect. Secondary free radical is more stable than primary free radical. Again, these two free radicals reacts with chlorine. If primary free radical reacts with chlorine, what is 1 chloropropane is formed. If secondary free radical reacts with chlorine, 2 chloropropane is the form. 2 chloropropane is formed. Here the 2 chloropropane is the major product and 1 chloropropane is the minor product. 2 chloropropane is the major product. Why? Because is 2 chloropropane is prepared from the more stable secondary free radical. More stable secondary free radical. That's why this compound is a more stable compound, and this product is the major product. That is orientation. And the next one, reactivity and selectivity. Okay, on reaction with alkane, the bromine atom is less reactive and more selective than chlorine atom. Bromine atom is a less reactive. Bromine is less reactive and more selective. Chlorine is the more reactive atom. That means the less reactivity of the reagent, more selectivity of the its attack, or less reactive compounds. Less reactive compounds are more selective. When comparing with chlorine and bromine, here chlorine I am taking butane, N butane. N-butane reacts with chlorine. It will form 1 chlorobutane and 2 chlorobutane. Is the mixture of two products, 1 chlorobutane and 2 chlorobutane. Here 1 chlorobutane is 28% and 2 chlorobutane is the 72%. Whereas bromine reacts with same N-butane. Here is also two products are possible. One is the 1 bromobutane and second one is the 2 bromobutane. But 1 bromobutane is the only 2%, but 2 bromobutane is a 98%. 2 bromobutane is a 98%, because of chlorine is a most reactive than bromine. When comparing with chlorine and bromine, chlorine is the more reactive compound, so it cannot be differentiate both primary and secondary hydrogen atoms in the butane and give one chlorobutane and two chlorobutane mixture. Here, but you can take bromine, but bromine is a less reactive compound. Bromine is a less reactive compound and it more selective compound. When bromine is reaction with butane, bromine is reaction with butane, it selectively forms two bromobutane. Selectively form two bromobutane. One bromobutane is a very less percentage. And that means two bromobutane is a major product. Here bromine is the less reactive and more selective than chlorine because of the electronegativity and reactivity of the compounds. Only simple chlorine is more reactive, bromine is less reactive. More reactive compounds are less selectivity or less reactive compounds are having more selectivity. Is the and reactivity of and selectivity of alkanes. Thank you very much.